Never stop learning, because life never stops teaching. We have a surface. On that surface there is a point. Well, we are interested in calculating the equation of the plane tangent to that point. Okay, here are the three-dimensional Cartesian coordinates. There is a curved surface. This surface has the equation phi as a function of x, y, and z. On the curved surface there is a random point. Let's call it point P. The coordinates of point P are x0, y0, z0. We can draw a plane surface that passes through point P. It can be said that the plane surface touches the plane surface at point P. Now we want to calculate the equation of this plane surface. Phi is a function of x, y, and z is the equation of the curve if the gradient is viewed in 3 dimensions. Different from f as a function of x and y, where the gradient is viewed in 2 dimensions. When viewed in 3D view, grad phi is a vector normal to the plane surface that passes through point P. Thus, the normal vector passing through the plane surface is vector n equal to grad phi at points x0, y0, z0. Now assume that on the plane surface there is a point Q that has coordinates x, y, z. We can draw vector r from point P to point Q. Thus vector r is x minus x0 I hat, plus y minus y0 j hat, plus z minus z0 k hat. Because vector r is on a plane surface and grad phi is normal to the plane surface, then the angle between vector r and grad phi is 90 degrees. Based on the concept of dot product, grad phi dot vector r is equal to 0. Or vector n dot vector r is equal to 0. From here we can calculate the equation of a plane surface. Okay, the first step is identification. Based on the information from the question f is equal to 4xy minus 3y squared. The points on the curve are 1, 2, negative 4. This means that x0 is 1, y0 is 2, and z0 is negative 4. The next step is to determine the function of the curved surface as a function of the 3 independent variables. F as a function of x and y is nothing more than a point on the z-axis, or a value of z. In other words, z is equal to 4xy minus 3y squared. Or 0 is equal to 4xy minus 3y squared minus z. Now this function can be considered as a new function. Phi is equal to 4xy minus 3y squared minus z, where phi is 0. The third step is to calculate the normal vector. The grad of phi is equal to partial phi partial xi hat, plus partial phi partial yj hat, plus partial phi partial zk hat. Plug in the value of phi. The partial derivative of phi with respect to x is 4y. The partial derivative of phi with respect to y is 4x minus 6y. And the partial derivative of phi with respect to z is minus 1. Thus, the gradient of phi is equal to 4y I hat, plus 4x minus 6y j hat, minus 1k hat. The normal vector at the point x0, y0, z0 is 4 times 1 I hat, plus 4 times 1 minus 6 times 2 j hat, minus 1k hat. The result is equal to 4 I hat minus 8 j hat minus k hat. Now we can calculate the equation of the plane surface. The vector n dot vector r is equal to 0. Plug in all the values. Simplify the equation. For x minus 4 minus 8y plus 16 minus z minus 4 is equal to 0. Or 4x minus 8y minus z plus 4 is equal to 0. This is the equation of the plane surface that passes through the point 1, 2, negative 4. Using the computer, here is the function of 4xy minus 3y squared. Here is the point 1, 2, negative 4. Here is a plane surface. This plane surface has the equation 4z minus 8y minus z plus 8 equals 0. Hopefully useful, and don't forget to watch the next video.